Welcome back again to our YouTube channel. Today we are looking at an exam question based on wave grade 10. So first thing that you need to understand, you are looking at the diagram. We are given two waves that are moving on the same point of rest. So we are given wave Q, which is the dotted one, and wave P, which is the one that is in bold. So what you need to do before you attack any question, you need to check your diagram or whatever you are being given. So if you are saying from this rest position is our time, which is got 1,5 and 3,0 seconds, and then we've got points A, B, C, and D, and then we've got our y-axis, which is -5, then the 0, then 5 up to 15 millimeters, and then we're given a distance from B to point D is 100 millimeters. So you need to first analyze the diagram. Now let's look at the question. It says question number 1, write down one difference and one similarity between wave P and wave Q. So let's look at the diagram. Our diagram is having two pulses that are moving at the same time. So if you look here, the amplitude are not the same. That's the first difference that you analyze. This is the amplitude is 15, the amplitude is 10. So that's the difference that we have on here. Then if you look at the frequency, it's have the same frequency, the same period, and the same type of wave. That's your answer for that one. So you're saying what is similar, there is the period, the frequency, and the transverse phase. And then the difference is the what? The amplitude. Then 6.2.1 says for wave pattern P, P is the one that is in bold that we are looking at, where we've got those points A, B, C, and D. And it says now write down 2 points that are out of phase. So you must understand this word out of phase. What does it mean? It means that 2 points that are not at the same distance, that are not doing the same thing at the same time. So if you look at a point, let's look at A and B. It's the first one. Let's look at C and D. It's also out of phase. Let's look at B and C. It's also out of phase. Let's look at A and D. If you look at this point, they're not doing the same thing. They're not at equal distance. That's why they're saying points out of phase. So we've got those points A and B, C and D, B and C, and A and D. Now let's look at the other question. It says the amplitude of the wave. So you're still dealing with P. So if you look at P, our amplitude there is at 15 millimeters, which is 0.015 if you convert it to meters. So if you divide by 1,000, it's going to give you 0.015. Now 6.3 is saying define the term frequency of the wave in width. So you're saying the number of wave pulses passing a point per second. So your 2 marks comes from the first one, which is number of waves pulses passing a point per second. That's when you get another point there. Okay. Then 6.4 is it for wave pattern Q, calculate the frequency of the wave. Let's look at Q. Q is the one that is running there in between. So here, remember we use one complete wave or one complete cycle. So here we're looking at this point. So we're saying our frequency, remember our formula for frequency says it's 1/T. So our time is this one, which is 1,5. That's where we've got a 1 complete cycle. So we're saying then our frequency, so our frequency is 1 divided by time, which is 1 divided by 1,5, which is going to give us 0.67 hertz. Okay, that's for that question. Now it continues to say find the speed of the wave. So speed, how do we find speed? We don't know the speed. Yes, we are given the frequency. Do we know the wavelength? No. So where do we find the wavelength? We look at the diagram again. So if we check at this point and this point D, this is going to give us one complete wave. So saying one complete wave is covering a distance of what? Of 100 millimeters. If you convert it, it's going to give us 0.1. Now we have got our frequency, our wavelength. So we're saying now the speed is equal to frequency times the wavelength. which is our 0.67 times 0.1. Remember, we use the size of one complete wave length, so it gives us 0.067 meters per second. Or we can use this one, which says speed is equals to change in distance over change in time. Your distance there, if you check on the diagram, is 0.1, and your change in time is what, 1.5, which is also going to give you the same answer, which is 0.067 meters per second.